A more common type of question is a type that involves volume and area. Okay, so before you continue, please make sure you know the mensuration formulas for volume and area of cone and volume and area of the cylinder. Okay, so the question will tells you some information where the cylinder has R and height H. The slant height of the cone is 3R. Okay, now next is they tell you that the volume of the cylinder is 96. Why do they tell you this piece of information? It's so that you can make H in terms of R. You look at all the formulas over here. The right side has R and H, R and L. You cannot differentiate when there's two variables on the right side. All right. So first, I need to say that 96 pi, which is my volume of the cylinder, is equals to pi r square h. H in terms of R means I make H a subject. H is equals to 96 pi over pi r square. Cancel and cancel. That's how I get 96 over r square. So that is the expression for H. Okay, in part 1. All right. Part 2. Then the question will ask for the total surface area. Total surface area of this whole thing. All right. So do it step by step. You can say that A, which is the area of the whole thing, is equals to the area of the cone, pi RL. Again, you see there is two variables here. Plus curved surface area of the cylinder, 2 pi RH. Okay, then don't forget to add the bottom, which is pi r square. And then now, let's replace all the non-R in terms of R. Pi R, the slant height L, they actually already very nice tell you that this is 3R. If not, sometimes you got to use either similar triangle or Pythagoras theorem to find out the R. Okay, plus 2 pi R H, you also already have 96 over R square. Okay, plus pi R square. Okay, expand everything. This is 3 pi r square plus 2 times 96 is 196 pi over r, because this r and this r will cancel. Okay, sorry, it's 192. Okay, plus pi r square. So total you have 4 pi r square plus 192 pi over r. You must give exactly what the question wants. So I factorize out a 4 pi. I will get r square plus 48 over r, and this is what the question wants. Okay, so first part forming the equation. Okay, next. Given that R and H can vary, they will always say this kind of information not important. That means R and H are variables. Find the value for which A is stationary. Again, stationary point. What's the concept? So now you have A is equals to 4 pi bracket R square plus 48 over R. This is the equation in terms of A and R. When I differentiate, it's called dA over dR equals to 4 pi. The constant, always leave it outside. 2r plus, in this case, let's make sure we make it linear first. R square plus 48r to the power negative 1. So I power bring down negative 48r to the power negative 2. Okay, yes, make it nice. This is equals to 4 pi, open bracket 2r minus 48 over r square. Okay, so for stationary point, what's the concept? So for stationary A, what's the concept? dA over dr is equals to 0. 4 pi, open bracket 2r minus 48 over r square is equals to 0. Bring the 4 pi over, you get 0. 2r minus 48 over r square is equals to 0. This type of question, very standard. When it comes to this part, always bring the negative to one side. 2r equals to 48 over r square, then just cross multiply. R cubed, 2r cubed equals to 48, or r cubed equals to 24, and r equals to the cube root of 24. Use your calculator, you can work out the answer. Okay, so then remember the second step. After you get the equation, differentiate, equate to 0 to find the unknown. Okay, now let's look back to the question. Determine whether the stationary value of A is a maximum or minimum. So this is where we do the second derivative test. I write out where is my dA over dr first. My dA over dr is here, which is 4 pi open bracket 2r minus 48 r power negative 2. I differentiate again d2a over dr square. 4 pi, keep it there. 2 plus, because bring down 48 r to the power negative 3. That would means 4 pi bracket 2 plus 48 over r cubed. And this answer will always be greater than 0 because r is greater than 0. Okay, so if the second derivative is greater than 0, a is a minimum. When r is equals to your answer over here, put it there. And if the question asks you to look for the a, subtract the r into the a to get the answer. Okay, and this is how you solve a typical maxima and minima question.